Welcome, Form 4, Physics, Topic 6, Optics, Notes, Lesson 17. You must have watched Lesson 10 until 16 to better understand Lesson 17. And in today's lesson, we are learning total internal reflection. This total internal reflection, it only occurs when the light ray moves from medium of high density that is more dense to medium of low density that is less dense. So remember, total internal reflection, it will occur when the light ray moving from high density, more dense, to low density, less dense. Now we look at medium 1 and medium 2 with a boundary in between the two medium. I have medium 1 high density, medium 2 low density. I have an incident ray approaching the boundary with the angle of incident I, okay, which I'm labeling it here with red. And then, if you remember on our previous lessons, that the speed of light ray is inverse to the density of medium, and also the speed of light ray is proportional to R, angle of refraction. So in our situation, we have light traveling from high density to low density, which means high density to low density. It means our density of the medium is decreasing. Arrow down, decreasing. And since density is inverse to speed, so when density decrease, the speed of light ray increase. And speed is proportional to R. So when the speed of light ray increase, the angle of refraction R also increase. Because the speed is proportional to R, so when the speed increase, R increase. Angle of refraction increase, which means the refracted ray is away from the normal line. So if you look at this diagram, the incident ray, and then the broken lines is the original direction. This is our normal line. Away from normal line will be on this side. It is away. This refracted ray is away from the normal line. Now what happens when I increase the angle of incident? When I increase the I angle of incident, the R will also increase. When I increase, R increase. Now what is the meaning of R increase? If you look at this diagram, if this R increase, the refracted ray will get closer to the boundary. So R increase, it means the refracted ray, it gets closer or nearer to the boundary. And this R will increase until the R becomes 90. The R angle of refraction will increase until the R becomes 90. Now what is the meaning of R becoming 90? That means if R is 90, the refracted ray is moving along the boundary. So if this R is 90 until here, this refracted ray now is moving along the boundary, which I have drawn here. You see? That is when R is 90, the refracted ray is moving along the boundary. I have drawn back the incident ray with the angle of incident I. Now, one of the most important things here is that when the R is 90, when R is 90, the I angle of incident is called critical angle, symbol C. So in this diagram, where the R is 90, where the refracted ray is moving along the boundary, this angle of incident I, now it is called critical angle, symbol C. I say this in another way, that the critical angle is the angle of incident. It is the angle of incident I. When the angle of refraction is 90. Now let me repeat that. Critical angle, it is the angle of incident. Over here, angle of incident. When the angle of refraction over here is 90. Now I've written this in sentence. I also can use symbol that the critical angle is symbol C. Critical angle is symbol C. So which means this statement in the sentence, I can use short form. That is, the C is I when the R is 90. Okay? C critical angle is the angle of incident when when R angle of refraction is 90. Now we come to the most important part, that is total internal reflection. As I said earlier, it occurs when the light ray moving from medium of high density to medium of low density, and the angle of incident more than the critical angle of the medium. So when total internal reflection occurs when light ray moving from medium high density to medium low density, and if the angle of incident I more than the critical angle C, the incident ray will be reflected. So if you look at this diagram, I have medium 1 high density, medium 2 low density, and this light ray moving from high density to low density, and this angle of incident more than critical angle C. You notice that the incident light ray, it is not going to the second medium, but it is being reflected. So moving from high density to low density, and the I more than C, the light ray is reflected. Occurs reflection. Okay? Now let me rewrite this again in a more simpler way. So total internal reflection. This word is telling reflection. So total internal reflection, it is a reflection of light ray. That's all. Total internal reflection, it is a reflection. Reflection of light ray, it is reflected from the boundary of the two medium. The light is reflected from the boundary of two medium when the light ray moving from medium of high density to medium of low density. This is the first condition. It must be from high density to low density, high density to low density, and the angle of incident I more than the critical angle. On the next lesson, I will continue total internal reflection.